Hello everyone. Now I welcome Dr. Bang Widigdow. He is from Department of Aquatic Resource Management, PB University, Indonesia. Thank you.
From IPB University, Bogor, Indonesia. I would like to share our research on hidden contribution of shrimp farm on blue carbon dynamics as follows. As we all know, that the shrimp farm is mostly constructed on mangrove areas. Many mangroves were converted into shrimp farm. This led to increase the blue carbon emission and contribute to climate change. Furthermore, climate change will influence negatively to shrimp farm itself, such as reducing survival rate and reducing growth rate for the shrimp. Environmentally, losing mangrove forests will influence carbon source, such as losing mangrove biomass, reducing carbon sequestration, and losing mangrove substrate. During shrimp farm operation, emission of carbon dioxide and methane will potentially also increasing. We do hope that the pond operation would have positive contribution through carbon dioxide absorption, increasing carbon stock, and increasing carbon donor. The purpose of study was to determine the flux of carbon dioxide and methane, determine carbon dioxide absorption and carbon stock from shrimp farm which were operated extensive or traditional method, semi-intensive as well as intensive system. The research was held in April to July 2019 in shrimp farm development project belong to Government of Indonesia, West Java, Kerawang. The research involved 9 ponds, 3 ponds each for extensive ponds, semi-intensive ponds, and 3 ponds also for intensive culture system. The parameter we observe and analyze are as follows, like in this table. The result of the research, unfortunately, during the research were, however, not running smoothly because farmers surrounding the research area burned straw trash on the day of the sampling. This influence, of course, the data analysis, especially on carbon dioxide emission. So some data should be eliminated. Flux of carbon dioxide and methane. The daily maximum carbon dioxide flux from ponds water was released by semi-intensive operated ponds, and the minimum was released by intensive operated ponds. The daily methane flux from ponds water released by extensive operated ponds, and the minimum was by intensive operated ponds. And if we talk about the yearly of carbon dioxide and methane and global warming potential, this is as follows. Carbon dioxide emission was from 2 sources. One, from water, means from biological processes, and second, from energy consumption or fuel burning. The yearly carbon dioxide emission maximum was found in intensive operated ponds, while followed by semi-intensive and extensive operated ponds. For the semi-intensive and intensive operated ponds, the emission from electrical energy was significantly higher than from biological processes, while those from extensive pond was almost equal from biological process and from electrical power. Methane emission was only from ponds water or biological process, and the maximum was found in extensive operated ponds and followed by semi-intensive and intensive operated ponds. Comparing the yearly maximum emission of carbon dioxide and methane from intensive operated ponds with other common operations such as paddy field and peatland irrigation canal resulted that shrimp operation considered to be much lower. And if we further consider the potential contribution of global warming, the intensive operated pond contribute the highest compared to two other operation methods in semi-intensive and traditional ponds or extensive. But this was still much lower compared to paddy field and almost the same to peatland irrigation. Carbon dioxide absorption and carbon stock. The maximum daily carbon dioxide absorption was found in intensive operated ponds and followed by semi-intensive and extensive operated ponds. Consequently, the maximum carbon stock was also found in intensive and followed by semi-intensive and extensive operated ponds. If we compare the yearly carbon absorption and carbon stock, all technology of shrimp ponds were far below natural mangrove. The daily maximum carbon absorption was found in intensive operated ponds and followed by semi-intensive and extensive operated ponds. The daily maximum carbon stock was found in intensive operated ponds and followed by semi-intensive and extensive operated ponds. So, if we come to absorption, the carbon dioxide absorption is maximum found in intensive culture system followed by semi-intensive and extensive. Meanwhile, carbon stock is be found the highest also in intensive pond and followed by semi-intensive and extensive pond. But all of this, if we compare to natural mangrove, for carbon absorption is still far below natural mangrove, and as well as carbon stock. We come to conclusion that carbon dioxide emission in shrimp-operated ponds mostly come from engine operation because burning fuel, but methane comes solely from water system in the pond itself. So carbon stock is the highest produced by intensive operated ponds and the lowest from extensive system operation. Phytoplankton contribute significantly for biomass of phytoplankton, and the greatest found in intensive culture system and the lowest in extensive system. Thank you.